Alright, so I'm Patrick Hardison. I spent the last, I guess, almost a year making this clock right here. And so this presentation mostly is going to be walking through like the steps I used to make it, kind of the things that inspired me, and kind of just how the whole thing works. There's going to be a little bit of technical stuff, but I'll try not to put you guys to sleep. Yeah, so here's the final project. Final project, obviously. It's easier to see in the dark. I could put it in the box, but yeah, you can kind of see the lights here. And yeah, so the four big, I guess, yeah, steps to making this is the pre-project, like all the planning, all the inspiration, yeah, all like the prep work, and then there's the hardware, which are like the physical circuit boards that I had to all solder manually, which was so much fun. The software, which is the code that runs the whole thing, and then finally assembly, which would be a box. There's some 3D printed parts in here, and of course the laser cut numbers. So starting with the pre-project, so all the stuff before you start building. In math class this year, we learned the design thinking process. So this is a super powerful tool. All like professional companies and stuff use these set of steps to design products for people. So empathize, you're interviewing people, you're figuring out what people have problems with. Defining is really narrowing that down to one single problem you want to solve. Ideating is just coming up with a whole bunch of ideas to see what sticks. And then prototyping and testing is creating like a cheap model and then seeing if it works. This is super, super useful for making products that are actually functional, right? But I have one thing that doesn't really sit right with me. And so, I step the first two and replace it with, wouldn't that be cool? That's my personal philosophy. Is it's fun over function. So it doesn't really matter if something works well or is useful or solves problems if it's just really cool. So yeah, so that's the philosophy I used, and then this is a fantastic video if you've never seen it before. This really exemplifies that. The ketchup robot. This is a fantastic video. Yeah, so fun over function, right? My personal philosophy is that self-motivation is the most important thing. Because I know for a fact you guys relate to this. If someone tells you to do something, and you don't actually want to do it, it's not going to get done 100%. So that was my number one driving force behind this is you've got to be self-motivated. If you want to actually do it, it's going to get done. And that goes with the no fear of failure. Because if you really want to see this final product made, you're going to try as many times as it needs until it works. And it's fun. And here, okay. If you take one thing from this presentation, go to Michael Reeves on YouTube and watch every single one of this man's videos.
So fun.
They're all fantastic. They're all no, okay. I would show it a little bit too vulgar to show it, but yeah, you can see they're all absolutely fantastic. He's like a super smart guy, and then he makes a laser tracking robot that just blinds you, and that's all it does. So yeah, 100%. Watch all this guy's videos. It's worth your time. Okay, previous experience. So yeah, I didn't just jump straight into this clock with no other background. I've been working on electronics like this with Arduinos and Raspberry Pis for a while now. This is one of the first things I did is a word clock. It was kind of like a kit. So you download the code and their board and then 3D print the plate to it. And then you have a cool clock that reads numbers. I don't know where it is, but I did make one of those at one point. That's going to come back later. And here's one of the first things I did, like really on my own, was this. It's a specifically made Tetris controller, which is kind of fun. I 3D designed and printed the base, and then soldered all the buttons on. I hooked it up to an Arduino. And yeah, I just used the controller. You can play Tetris with it. And then, so a thing project I worked on for so long is I got the controller. Like, wouldn't it be cool if I could make my own like video game console to just have around? I could carry it. Speaks for itself there. We'll call it a learning experience. It did not work very well. It broke about 10 minutes after that picture. But I learned a lot from it. That it laid the groundwork. So, you know, all experience, if it fails, if it works perfectly, it still works. So, next big inspiration, Nixie Tubes. So, yeah, my history knowledge is a little rough. I Googled this a little bit. But these are invented by Soviet Russia, I want to say, in like the 1950s. And they're really like the first way that people display digits. I think the way it works is it's basically like a whole bunch of neon signs like in a line, and it just lights up the one that has the correct number on it. And I think they're just awesome. Like having a clock made out of these is like, that was really like one of my biggest inspirations, just because I think it looks sick. Also, Steins Gate, I'm outing myself a little bit. It's a time travel anime. Fantastic. Highly would recommend. But they make this Nixie Tube clock. It's the divergence meter. Basically, it just tells you, or in the show, it tells them like how far away from base reality they are. So if they time travel too much, the clock goes wild. Original plan was to make one 8 digits long like that, so I could like have a clock mode or use it as a divergence meter like in the show. Didn't turn out like that for a couple reasons that I'll get back to later. And if I forget, yell at me, because that is a possibility. And then also, I'm broke. I would buy one, but these things are very expensive. Nixie Tubes, they were only really made in the 50s and 60s. They're all really novelties now, so the only ones you can buy are old ones that have been refurbished, or like the 3 companies that are making newer ones and charging ridiculously high prices for them. And so I thought I'd make my own. And that's how this really all started. Next is Angelito Acrylic. You can now see all these pieces coming together. Really cool thing you can do with this clear plastic is if you engrave words into it and then shine a light from underneath, it will highlight all the things you engraved into it. Although, hey, instead of using the gray tubes, let's line up all of these in a row and just light up the number that I want to use. That's fantastic. I'm sure no one's thought of this before. So here's a guy that did the exact same thing. I mean, okay, so I'm not the first one to do it. His is rainbow colored, so it's superior. But, you know, I think this is still very much valid. His is a little bit different in the way that the pins work, and also it's $30 per digit. Still very expensive. Mine is much less than that. Yeah. And so, all right, that's, I guess, the end of the pre-planning, and now I'm going on to like the actual steps to make it. So if anyone has questions so far about anything, or I guess questions anytime during the thing, just raise your hand and yell at me or something. Okay, so the hardware. Basics, electronics. So you have a battery or a load, and you attach the positive end to one end of the LED and the negative end out the other into the battery. And the trick with that is that it's got to be a closed loop. So if you just attach the positive and not the negative, nothing will happen. You just attach the negative and not the positive, and nothing will happen. You have to have those connections active for that whole circuit to be formed and the light to light up. This resistor here, a fun story about that. Batteries provide a lot of amperage, and LEDs can't really handle that much amperage. So resistors are there. It's kind of like kinking a hose to stop all the water from going through. I tried once to hook up an LED without the resistor and see it to be brighter. It quite literally explodes. Which is, yeah, not really fun if you're not expecting it. And so, the next step of this is a matrix. So, in this diagram, instead of having just one LED hooked to a positive and negative of battery to light it up, you have a whole matrix of them, a whole grid of them hooked up in a row. So these all, the anodes, or the positive terminals, are attached vertically, and then all the negative terminals, or cathodes, are horizontal. And so the way this works is if you provide no current to all of them except for one, so just have that one positive and that one negative, it'll light up only that one LED. So that would be on here, right, lighting up only, I think that's a 1 right now. I'm grounding the pin with this digit, and then raising the voltage on just that one number. Oh, let me just change. Yeah, and so that's how that would work. And then if you want a second light on there, you would just ground a second pin, and then raise the voltage in another one, right? Why does this not work? Shout out the answer.
If you did the middle one, you couldn't specifically say you wanted the dead center one only now. If you turned on that cathode, then you would also have your top anode come on.
I think that's right.
Yeah.
Yes.
You would have, you can't turn on two, like the row where you have two anodes, for instance. Or, like, sorry, you would turn on two, even if you wanted one of them.
Yeah, that's correct. So basically, the way this would work is that even though those are the two I wanted, because this one's positive and this one's negative, it's going to light up that one as well as that one. So it doesn't work. It lights up all 4 of them like that, and you can't really control it. And so the way to get around this problem is, instead of lighting them up all at the same time very nicely, is you have the computer flicker it really fast. So you can't tell because it's doing at like literally milliseconds speed, but it is actually flickering all 4 of them in a row on and off very, very quickly. And that's how it's lighting up 4 different ones at the same time. So that's how the matrix works. Or that's like the basic idea of it. And then here is the board that I designed. And I'm gonna actually pass these around just if you want to look at them. Yeah, don't be worried about breaking these. I'm not using them anymore. Yeah, it'll take a while to go around. We got plenty.
Did you come up with the flickering idea yourself?
Kind of. So that's yeah, it is a semi-known thing. A lot of displays like that use the same techniques. Yeah, it's not a novel idea. But yeah, I did write all the code for it. I'll go through that later. I did write all the code for the flickering on that. Yeah, and so here is the prototype board I used. All the testing of the code, like before this final block, I used these. This diagram here kind of shows how the whole thing is wired together. So this would be one column. You see all the negatives connected, all the grounds are connected, and then the positive ends, the anodes are just sticking out. And so then you raise that one, ground that one, and it'd light up that LED right there, if that makes any sense. And then the problem I ran into, yeah, that would make the, oh, I could also, I'll put this in the box. This is what I brought it for. You can see it much better in the dark. You see that all right? Alright, so we've got a weird viewing angle now, but...
Do you know where the light switch is on?
Yeah, if you can cut that light, that'll...
The one right next to that.
These are this the one that...
This one, there's the one next to there. That'd be this switch that's very. It's all the way back.
There's like 80
To your
light
left.
switches in this one.
That one runs
So right.
Oh.
There we go.
Hey,
Yeah, that's much better now.
And now it's on.
Yeah, so. Yeah, you can come up at the end and look at it. It is it's a little bit dim, but you can't really work around that. Or actually, I tried to make them brighter. These LEDs, if you put, or the resistor, I don't know if I want to explain that, but if you put more voltage into it, it'll be brighter. But the problem with that is the Raspberry Pi, or the Arduino I'm using, caps out at about 5 volts. If you try to feed it more than that, it'll fry it. So it is definitely possible to make it brighter, but I'd have to do some funkiness with voltages. Next, okay, so this is kind of that prototype board in action. You can see the, I've got this wire grounded here, and then I'm using that 5 volt to light up each specific LED. And that's basically what the clock is doing, just automatically. Yes. So here's the final design I used. Significantly more complicated. And this is the exact reason, this is the exact time I found out why all those other boards cost so much. Soldering that many pins nearly killed me. Right? I saved, what, like $50, $60 for making it instead of buying my own. It cost me a piece of my soul. I'm not going to lie. It took so long. So yeah, the way this works, this isn't actually really a great picture, but here I have 2 LEDs. There's one horizontally aligned with that, and one vertically aligned there. And then all the grounds for the whole thing are connected, and then the positives are connected just horizontally across the thing. So what that means is there are technically 2 LEDs on each light, but it's hooked up like there's just one of them there, just because of the way the electricity is passing through it. Does that make any sense? Just want to make that clear. Yeah. And so that's not a great picture. That's before I soldered these ones across. So I'm lighting up just that one without the one on the other side, which would be lit like here in a clock. And then here's the whole thing put together. Yeah, it was a pain. Again, part of my soul. It just took. It was just very, very tedious to solve them all together, but it does work.
How long did it take you?
I don't know exactly. I wasn't super diligent with it, but I was soldering pretty significantly for like 2 days, so like 5-6 hours. Not fun. Well, I think it was working in the end, though. So don't let me be too pessimistic here. All right, and that's it for the hardware. So any other questions over here? Again, there's we'll have some time at the end, but.
Okay, Patrick.
Just trying to.
So what drove you from your initial board, that was kind of just several lights across, to this super complex board? Like, what was the thing that made you go from the first design to the second?
That is a very good question. So first of all, I think it'd be kind of tough to see in the diagram, but this new board is actually more compact than the old one. Like it's horizontally takes up less space, which means the numbers would be closer together and just kind of look nicer. And second of all, the LEDs aren't very bright. So having 2 of them next to each other, having 2 of them powering each number would just make it easier to see. And that's the main reason. And I think I forgot to mention this before, I'm kind of all over the place, but the reason I did use Nixie, I used these instead of full Nixie tubes, because 1 Nixie tubes are crazy expensive, and 2 they run on 120 volt, which is a lot. That's what comes out of a wall socket. So I don't really want to mess that up and kill myself. So I decided to use 5 volt LEDs. instead. Yeah, I do not trust myself with high voltages just yet.
Did you ever like shock yourself through this?
These voltages aren't enough to really shock yourself. Again, the biggest scare I had was exploding no one LED. Which was, yeah, kind of fun. Who wants to put up in the cushion? Okay, and now the software part of it. So the whole thing is powered by an Arduino. An Arduino is what is called a programmable microcontroller, which is kind of like tech jargon for a very small computer. So you can plug that in. What's inside there? You plug it into a normal sized computer and upload code to it, and then it runs that code. And that's about it. It has all these pins on the side, and these are how I'm controlling each one of the LEDs. You can alter the function of each of these pins to make the whole thing work. And if you're interested, the code it runs in is C++. Here's the pinout of it. So this is what each pin kind of does. I have the clock board I'll talk about later. Those are the analog pins, and then these digital ones are the ones that I'm manipulating to ground specific panels and to light up the other ones. So actually programming the thing, it has it's pretty simple. It has just two main functions in it, which is like a setup and loop, and they're very, very self-explanatory. You put your setup code in the setup, and then in the loop code, it'll continually, like while it's plugged in, it'll just run through that code over and over and over again. So, yeah, updating all the code is in the loop, and then prepping everything is under setup. And so, I'll go over this pretty quickly, but this code is all it takes to light up like a set of numbers. So what this is taking an array. I called it time, like the plant time, because like the normal time is like a special function, I think. It doesn't like being named that, so it's the plant. Yeah, so it takes an array of numbers and basically lights up that series on the board. I have these two functions here that do that. Yeah, I won't bother explaining that. If you know if you know what the code is, you'll just kind of see what I'm going for. And if you don't know what code is, you're falling asleep yourself. Moving swiftly forward. Here is kind of the whole thing working. This is an early prototype of it. And here you can actually see through the camera lens, you can see it very faintly strobing, and that's that flashing on and off. Yeah, again, completely invisible to the naked eye, but if you've got weird refresh rates on your cameras, you can see them blink. And yeah, that's the LED matrix, and it's planned another time. Thank you. Next big part of the project is actually getting the time. So remember this word clock from before that I made. The board that it comes with is that one right there. It is the Adafruit RTC DS1307. RTC, I think, is just real-time clock. And so that board is what actually gets the time on this word clock. And funny thing about that board, I have absolutely no idea how it works. Because it automatically does like time zones and everything. It's kind of magical. I don't know if it's a radio. I don't know if it's communicating with the computer. I don't know if it's reading like mystical ley line energy to get the time. I have no clue. But the cool thing about that is that this clock kit came with its own code. Like it was a kit, so it came with the code that it used. And that code is what drives that. So I may have no idea how it works or what code it needs, but I have the code already. So here, I'm gonna let you in on a little secret. This is the 3 keys you need to become a programmer. Right here. Okay, so I'm not encouraging plagiarism, right? Don't go Google the answer and submit that as a computer science homework. But when someone's already done the code for you, there's no reason to do it again. And I know enough about the code that I know which parts I need, which parts I don't need. So I kind of just yoinked the code. And that's how it works. And so that board now is getting the time somehow, and I'm turning that into the array that I can display on these numbers. Yeah. And then here's assembly. Just any more questions so far?
So
Yes.
does your Arduino have to be plugged into your computer, or can it get power source somewhere else and then get the time?
It is currently only getting power from this computer. So yes, you can plug it in anywhere and it will display the time. So yeah, that's what that one board is for. And there's a little bit of funkiness with that, but I'll get back to that a little bit later.
How do you set the time?
Again, the code does that automatically. I think it does read it from the computer.
So in the code that you wrote or joined, you can set your time zone then?
It does it automatically. I think, yeah, I actually did look it up later. But it reads the time, it gets the time off the computer and puts it on the board. And so whatever time zone your laptop is in when you upload the code is the code that works. So I got a little bit of movie magic on there, but you know. Okay, so this is kind of the final step, which is have all the components. Now we put it together into a box. Here's actually making the box. It's my dad. Shout out to him. He's big on carpentry, so he helped a lot with this part. Measure out the dimensions you need, cut the wood, glue the wood, stain the wood. You got a box. It's pretty simple. This is like the bare minimum box design. Like, you really can't go more simple than this. I think it turned out really nice though, so I can't really complain one bit. And here, so this is a diagram of it. If you took a cross section like that, this would be what you're looking at. And so, yeah, this would be the box. That's the actual circuit board that you saw before. And these three are all 3D printed, or 3D designed and 3D printed little extra parts in there to help keep the whole thing secure. First of all, is this light shield. So, yeah, the purpose of this is kind of evens out the whole thing. So you're not trying to like balance the acrylic numbers on top of LEDs, which is ridiculous. Yeah, so that evens it all out. And also helps isolate the light. So if we didn't have that thing there, like the LED for, that's a 6 right now, the 6 would light up, and it not only light up the 6, but also light up the 6 and 8 around it. 7. Wow, okay. You use that to isolate the just the correct digit that you want. And the way to design that is, so there's a couple ways you can 3D design things. I tried using Fusion 360, which is a big like professional companies use all Fusion 360 design things. Super powerful, super precise, ungodly complicated. I spent so long trying to figure out how to get it to work, and it's really, really amazingly difficult to use. And so I use a program called Tinkercad instead. It's like the MS Paint of 3D design. And so I did it very imprecisely, basically by trial and error. So I printed a tiny little cylinder to test the width to go around an LED, then strung a bunch of them together in this middle section to test the spacing between them, and then finally turn that both sides into that board there. And I think it turned out really nice. It does its job perfectly, so all good there. Next is the number spacers. That is that silver thing on the bottom. This one's super simple. It just holds the acrylic panels in place. There really isn't anything special there. I did line it up. I lined up the spaces over the LEDs. So everything's like even, and everything's lighting up the correct number.
Patrick?
Yeah.
How do you light up just the number and not like the whole plastic layer?
That is a good question. And so that's just the weirdness about the plastic is that the whole thing is smooth. And I'll pass these around a little bit later. I'm not sure exactly how it works. This is not my specialty, but basically, since the whole thing is clear, nothing is really catching the light except for this rough part that is engraved into it. And so the whole thing is being lit up. You can see, if you look at the top and the sides, you can see like the edges of the acrylic are being lit. So the whole thing does have light in it. It just goes straight through it because it's clear until it touches the engraved parts.
Okay.
That's a good question. And again, yeah, just shout something out if you have questions. Next, just printing the numbers. I used to buy acrylic at Home Depot. It was like $20 for a whole big sheet of it. And then here, Dr. P remembers this. I was in the laser cutter room for forever, just tinkering with the thing, figuring out the best combination of settings to have the best number. Yeah, so the laser cutter, if you're not familiar with it, it's pretty self-explanatory. It's a laser that goes through and can engrave the plastic. So I went through all these permutations and originally decided the best one was the one Google told me before I started. So, good use of time. We'll call it a learning experience. And then this is the, over here, is the final design I settled on. You can see over here that these are solid, and then the final one is just the outlines. That was because with solid numbers, having so many of them like back to back in a row makes the one at the very end very, very hard to see. And so, yeah, having just the outline makes them all much more visible. And I will pass these around and just want to check them out.
Patrick, while you're taking those around, was there any, are the numbers aligned in their holder and their spacer sequentially, or is there like a preferential, like, weird pattern instead of like 0 to 9?
These are, I think, yeah, I'll talk about it a little bit later, but it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the decimal place in the end. You could order it a specific way, just like which number is statistically light up the most to put in the front. That would be a really interesting way to do it. But it would also make the code much more difficult. And I don't know, the way it works, you can see all the way through the back pretty easily. So that ended up not being a problem. But that is a very good idea if the opacity of it was an issue.
Everything orders already which ones get lit up the most.
Yeah, I mean, yeah, just because it's not numbered work. But there's one panel on the back. They're actually 11 deep. There's a decimal point that never actually ended up getting used. That was when I thought I was going to do the full 8 long and have decimal points between like the hours, minutes, and seconds. Yeah, and I'll go over that again a little bit later. Why I decided to go with 4. Next, that's the 3D printer file. Oh, and you can see on the samples around. You engrave these upside down, which is kind of cool. And so then if you look at the numbers, if you look at them straight, it's completely flat on the front and engraved on the back. So that's just a little extra thing you can do, make it a little bit fancier. Yep, that's the Adobe Illustrator file that is on that program. And then here it is being lit up over there. Next is the support brackets. I can't really show you these very well, but they basically look like that. They're wedged between the box. Yeah, they're wedged like right here on every number, and they kind of just hold the PCB in place. Yeah, because it's a flat PCB and a flat wall. You can't really stick it to the edge like that. So you 3D print that bracket there to keep everything level. And so a cool thing is these all these PCBs the circuit boards that I soldered to, they have screw mounts on the sides. So it's actually super easy to, I mean not super easy, but you're supposed to put drill holes and kind of mount it all. And then you can have everything screwed in nicely. It's easy to unscrew, very precise, and that works well. So I hot glued everything together. You know, it wouldn't be a school project if it weren't a last minute time crunch. So, you know, screws might have to wait. It's held together with hot glue and Reeves. And this is kind of what it looks like, I guess, under the hood. And so you can see the brackets there with the spacers on top of them, the LED shining through, and then all the wires kind of tucked underneath that. And then you put the acrylic sheets on top, and it's finished. And so, yeah, I think it really turned out. It turned out there about as good as I could have imagined it. It's not 8 long, and the reason for that is I actually completely ran out of pins on the Arduino. Like, there physically is not enough. I couldn't add another 4 digits. And I actually, the decimal place isn't used here. I actually had to desolder that out completely just because I had to fit the, the 10 numbers, 10 numbers and then 4 ground pins. Completely maxed out the Arduino. And then, what's next? So what's the next step? Because product is never really complete. Like, they've been making new iPhones for 20 years at this point. There's not like a definitive final. So, definitely a few ideas. You could make one 8 long. I'd have to work on a little bit of weirdness to get that working. The original plan was to have custom designed circuit boards and have them printed and shipped to me. Should have been really cool. Saved on the soldering, but didn't really work out. Shipping took like a long time. And you know, school projects, I'm not fantastic at time management, so a lot of this was the last 2 weeks. Just full transparency there. I think it might have been Jack Sorensen talked about adding USB ports to charge the phone off of it. Was that you?
That wasn't
you. It was someone. I'm sorry. It was someone. That's not a bad idea. That would be pretty easy to add. I was thinking alarm clock would be cool. That I don't think would even be too difficult to add an alarm feature to it, to put some buttons on the back. And then here, okay, so I gotta complain about something. On our community members, show of hands. Right? Okay, I completely lied to you. The board that gets the time decided to quit at 8 o'clock last night. Still not exactly sure why. Could be like the chip could have shorted on something, solder could have come undone. I'm really not sure, but that just quit. So 10 o'clock last night, I wrote basically the code equivalent of duct tape to get the time displayed. If any like self-respecting computer programmer saw the code that is uploaded to that thing, they would slap. So next step, like imminently, is getting that board to work again. But yeah, for demonstration purposes here, it works perfectly. And I think that might be about it. If anyone has questions for the whole thing, yeah.
How much did it take? I mean, how much did you spend to for all the parts and stuff?
Yeah, so I tried to calculate this out and then cut that slide actually, but that's a good question. So I added it all up together. I want to say it was like $60 to $80, which is really not too bad considering the alternatives were $200, $300 plus. So yeah, like monetary investment wise, not too bad. Yeah.
Can it show different colors? Can it show different colors for the numbers?
So this cannot show different colors. These LEDs are just orange. You can definitely get LEDs to show different colors, and that is very possible. But it would either be the two ways you can do they're called RGB LEDs. Is you have LEDs that have a chip inside them, like a driver inside each LED. They're called neopixels. And that one you can do. It's easier to solder because you can just put them all in one data line. But the problem with that is I don't know how they work, and they're also much more expensive than normal LEDs. The other way to do RGB is you can buy LEDs that have, instead of a cathode and an anode, it has one ground and 3 different anodes for red, green, and blue, which would have quadrupled the soldering. So no, I'm not doing that. But yeah, having it be rainbow colored, it'd be awesome. But the orange is like a classic look, and I think it turned out well. Yeah.
What were your major distractions in making this?
Major. I'm really, my time management skills not up there. So you know, a lot of this was done a little bit hastily at the end. But I think it turned out well. I do get distracted very easily. This Minecraft needs to be played. This chicken's not going to build itself. Thinking back, my priorities may have been slightly out of line, but it turned out well. It turned out well.
Your priorities were exactly in line.
Yeah. I'm right. Anything else? Gosh.
So the 2 first digits are like the hour, right?
Yeah, so you can see, hopefully this is still the right time. Yeah, 1:31, it's pretty close. So it's 0, 1, 3, 1. That's 1 o'clock and 31 minutes. Little fun Easter egg. You can tell what time last night I put this together. Don't worry about it. I built the Minecraft chicken, it's fine. Anything else? Yeah, Sebastian.
So since logically the first row would not be anything other than a 0, a 1, or a 2 if you're doing military time, could you have gotten rid of like half the...
I definitely could have. That would, if you're really trying to cut costs on like acrylic, that is very much an option. That's nice to point out. But I'd have to you'd have to design a new 3D printed parts for them. And it makes me happy to have all of them symmetrical, so my OCD would have killed me if I left one not a black. But yes, you could absolutely have had just the two digits there. John.
Can you technically make it into a calendar?
I could, with different code, you can upload whatever series of numbers you want on there. So calendar, absolutely, you could do that. You can also upload, I can make it do minutes and seconds. I don't know if I want to reprogram it on the fly. But yeah, you can put any series of 4 numbers you want on there. It doesn't just have to be time. Here, and that's another question. I did just want 2 panels here, so you could make it versatile.
I don't know how to ask this, but could you theoretically print anything on, not numbers, but images and those ups?
Absolutely, you could. Instead of numbers, you could really engrave whatever you wanted on them. And so, these decimal points here, not using them, you could put clip art in the back. I guess you could put whatever you want just to make it a little bit more fancy. And because I designed all of these numbers, you can change the font. You can change. Yeah, you can change anything about them. So yes, you could.
So follow up to that, just because you had the fun function thing at the beginning, there's some people who think that time is a human construct, and so have you been tempted to mess with that at all? With your experiment?
You know, actually, let me do this right now. It's gonna mess up the times, but it's kind of entertaining. You can speed it up. You can speed up time. Over that. That's the spaghetti coach part of it. It normally is more formal. It's not sped up enough. Let me just crank the mess out of it. There it goes. So now it's just moving.
Oh, wow.
So yeah, you can mess with the time if you want to. Yeah, that answers the question. Yeah, Jeff.
Could you use like Raspberry Pi? Like, why'd you use an Arduino?
So that is a good question. Raspberry Pi is basically just a stronger Arduino. I could have definitely used the Pi instead, but it would have been much larger. I didn't show it, but I didn't use the Uno in here. I have a much smaller board instead. But yeah, so you could have definitely used the Pi. It's a different programming language. But mainly, yeah, Arduinos are just slightly cheaper and smaller, and you don't need the extra processing power that the Pi has.
If you would have used a Pi, would you have had any extra pins to do any of the extra things that you wanted to do with this?
That is a very good question, and I have to check on that. But there's a good chance that if I want to do the 8-long one, the Raspberry Pi might be the way to go. I think we're pretty good. I don't know, about 10 minutes off. So.
Good.